Okay, so it sounds like a lot of like programmatic needs was the
was
starting place.
Yeah.
Did you have Python coding background, or did you learn it as need?
No. I'd done a lot of like Python coding because Python was my Swiss Army knife always. So there's so much you could do. I used to work with this small company in Texas, and I would help out with finding projects and whatnot. And like I would sweep the government website pages every day, trying to work public projects, that kind of stuff. And I had this Python script to upload and automatically email these stuff to my boss so he can figure out which one he wants to pick or not.
Nice.
So like I've been using it for a while.
Great.
That's funny. That's funny because I also started doing area calculations, in this case for Microsoft for tenant improvement stuff, trying to track where all the groups were. It was a little different though. It was AutoCAD 14 and it was Lisp.
Yeah.
So, but it is funny that the project was very similar.
Yeah, we pretty much did the same thing except in 2 different time periods.
Yeah. That's pretty funny. But yeah. We actually have a lot of architects that are working for us in the company. I would say because design thinking and design training works really, really well for programming.
We used to joke back in Iran when I was studying architecture that you go study architecture and then you go figure out what you actually want to go do.
Yeah, I've heard a lot of people do that as a background. And there were some people going into fashion design in my program, I remember.
There's a lot of people going to movie industry. Yeah, absolutely.
But yeah, Revit, it seems to me, is a very architecture specific program. It's so yeah, do you want to start showing us what you guys have been working on? And
yeah, I guess I kind of wanted to get a let me actually see if I can figure out this whole thing in here. I tried to, but I wasn't really successful. But I guess the main question is that we kind of wanted to get an idea of like how many of people here have actually used Revit, because I'm assuming most people are very familiar with Grasshopper. Revit users might not be as many, so that helped like me and Scott kind of figure out how much of Revit should we cover.
So perhaps if I can offer a suggestion, use one of these reactions down here in Zoom, like raise your hand if you've used Revit. Is that?
Yep, that's working. That's pretty cool.
Right.
That's actually nice. Yeah, smart.
Cool.
1, 2,
All right.
4, 5. Somebody's clapping. What is clapping?
Close enough.
Close enough.
All right. That's right.
1, 2, 3, 4, 5, 6. Okay, so like I would say like a third of the audience, maybe slightly less. Okay.
Andy's Mark Perry apparently celebrating Revit. And
Yeah.
Andy Brand, big fan too.
I need to amend. I actually hate Revit. I just clicked the wrong button. I use it way too much, and I'm trying to get the firm to push Rhino.
Oh.
Everything has a place. Yeah, you can't screw a screw in with a hammer. So I don't know.
That's right. Right. Not everything's a nail. So so Revit, the thing that we've done is if you look at what we have is with Rhino 7, what we did was we pulled Rhino 7 apart into pieces. And what that allows us to do is load it in a lot of different ways, because it's not just one application. It's kind of just a bunch of parts. And so one of the technologies that was part of that is called Rhino.Inside. So it allows us to take Rhino and Grasshopper, for that matter, and load it inside other Windows 64-bit applications. And one of the ones we tried, and unusually it worked, was loading Rhino and Grasshopper actually inside of Revit. And what it allows us to do is, allows you to do, is actually now have all the things you can do in Rhino and all the things you can do in Grasshopper and all the things you can do in Revit all in the same environment. And that's true with the interface, that's true with passing information around, and that's true with developing your own plugins or developing your own scripts or whatever else. And if we have time, hopefully Ehsan can show a little bit of that. But the idea is that now you can collect all these things together and make a smooth transition between what you might use Rhino for and what you might use Revit for. And for those of you that are kind of struggling, or there was comment about trying to use more Rhino, what's nice now is that you can have people use Rhino early in the process if you want, with the freedom and the flexibility that comes with being in Rhino. And then as the project transitions forward, you can use Revit either really lightly or really, really heavy. And that can change, even within the phases of a project. So a good example is if you had a competition and you modeled it all into Rhino really quick and you wanted to get some quick drawings, for instance, well, you can just, based on the layers, you can push all the geometry into Revit, and those layers can translate to categories. And then you can cut elevations and sections and all those things really quickly. If you were to change the model in Rhino and run Grasshopper with the script again, it will update all the drawings in Revit. That's a good example of what you could do in a competition. Now, the reason I say it's a competition, because we'd use direct shapes to do that, and direct shapes are fine for some things, but not everybody. The people that are really familiar with Revit know that direct shapes aren't the answer to everything. They're kind of a second-class citizen for a lot of different things, the way Revit works, and so you want to be able to move to something more sophisticated. And this is where it gets really interesting with Rhino.Inside, because now we can actually start to place objects within Revit schema to make it a well-organized BIM model, as the project, approaches production. And that information that you did in Rhino doesn't have to be completely remodeled a lot of times in Revit. And so that's kind of what we're looking at here. So I'm going to show you kind of how this loads. I'm going to show you just really quickly kind of some of the things to think about in Grasshopper when you're doing this and how Grasshopper is different. And then we'll maybe take some questions and kind of focus this on a direction that you're interested in. If you look at this here, if when you install Rhino.Inside, this, and it takes Rhino 7, by the way, but if you take Rhino.Inside, you get this toolbar here, and you can hit this button over here and load it. And this will load Rhino and Grasshopper in the background or inside the memory space of Revit, actually. And these become available up here. And if I open this up, what I get is let's just jump in here. I get a Rhino window here. This is actually Rhino, but it's Rhino that knows it's running inside Revit's memory space. So I have a Rhino UI, which I don't have to bring up, but you can see I have that here. And then if I click on Grasshopper here, it'll load Grasshopper, but Grasshopper knows it's running in Rhino, which is running in Revit. And so it does a few different things. In this case, it brings up some extra toolbars that you're not used to outside of Revit. So one of the things that we have is we have new params that are Revit types, or Revit types is not a good word because Revit uses that for something else, but Revit objects. Revit things like categories, families, line patterns, graphical elements, all those things. And these are things that you can use to select objects in Revit to actually participate in your Grasshopper definitions. Also, if I go to a Revit toolbar, which is a new toolbar that will show up if you're inside Revit, and this has a bunch of Revit specific categories. Like, let's say, work with assemblies. That's one that's very new, and that one's very cool. We'll get to an example of that maybe today. The ability to add beams and ceilings and columns, floors, roofs. These are adding and these are true Revit objects, you know, so just as if you had inserted them with Revit, you're just having Grasshopper do it for you. And that's what that is there. We can deal with categories. We can deal with direct shapes, like we talked about really quickly there. We can interrogate the document. You know, all those kinds of things you might think about. Elements, we can deal with Revit elements. We can select them, we can query for them, we can, you know, flip them, we can change their parameters, all those things you can do through Grasshopper to the Revit objects. We can deal with families, we can create new families, we can insert them, we can, you know, work with them, and I'll do that in just a second. We can deal with filters for filtering, selecting Revit objects, or Revit collections of Revit objects, and then do something with them in Rhino. We can deal with materials if you want to do materials. This is different modeling things like grids and levels. You can create those with Grasshopper and control them. Site information, views, layouts and views. We're continue sheets. We continue to work on that. And then over here we have the ability to deal with walls. Walls is such a big category that you know has its own toolbar here to do all this kind of stuff. So what I want to show here is I'm just going to open a definition that I have, and let's see here. We'll do. Let's try this one here, and this will open up Grasshopper definition, and what it's going to do. I'll show you what it does here. So I like to use Elephant a lot. So this is another interesting thing. All the plugins that Grasshopper runs will now run in Revit. So all the Grasshopper plugins now technically are running in Revit. And of course, they're running through Grasshopper, but they are running within Revit's memory space. So you can actually apply Grasshopper plugins to Revit objects if you want to do that. And so I just take a look. I use Elephant a lot because I like to deal with categories and layers. So in this case, what we're doing, if you look at this project here, we have a custom walkway, which might be kind of hard to do in Revit, just because of some of the unusual shapes. But one of the important parts is people that have used Revit a lot know that how do you categorize this based on, you know, based on how the project it's going to go together as a project. In this case, it's a custom walkway, and the concrete footings that we have here in Rhino, I want to be on a foundation layer, and then the rest of the custom construction here, I'm actually going to put on a site layer, but I need to break it down into subcategories. So what we do is I find all those footings through a filter, a layer filter using Elephant, and then I can grab making a family in Revit, and a family is, you can imagine a family is like a block definition in Rhino, but it's a collection of objects and information that exists as a definition in the header. So I want to create a new family. I want to create with structural foundations. If I click on here, you can see this is all the categories in Revit, and so but I'm accessing it through Grasshopper. And I want this the footings to be called canopy footings. That's going to be the name of this family. And then I'm going to go off and grab its type. Every family has types, and then types get inserted, like you might insert a block. And so then I insert that at a certain position, in this case 0, 0. And you can see what I get over here is I get that canopy, or I get the footings to that canopy. And those footings are done, are in this canopy footings, a structural foundation category called canopy footings. And so we can work with those, and somebody that knows Revit can then work with those in those categories properly. Now, in addition to that, what I want to do is I need to take the roof here, the glass roof and the structure and all these other pieces, all this custom components all welded together. And I need to put that into Revit too. So that's going to be under site, like an exterior site object. And in this case, though, I want to break these up into multiple subcategories. And so you can see we're going to start getting a little deeper into the Revit schema. And what I can do is map Rhino layers, in this case, columns, roof panel, roof beams, and frame, which are standard Rhino layers. But I want to map them to canopy columns, canopy panels, canopy beams, and canopy panel frame. So this allows me to control how those things draw in Revit when I'm creating drawings. And so a Revit person would come and, or if you're the Revit person, you can organize the objects in Revit coming from Rhino through Grasshopper. And then I'm also adding materials to those. So I'm adding Revit materials to those objects as they come in. So they come into, we add materials, we add subcategories, we push the geometry together with a subcategory and a material, and then we put that in our family. Then we insert our family again, which is the rest of the ceiling and roof here. And what we're going to get here is a live model of this. So if I change this in Rhino, then this would update here in Revit. And it's kind of neat because I can come in here, for instance, and if I do, let's take let's see if I do this. I can create drawings of this. You can see here that, for instance, I'm changing line weights and line types based on what this looks like. If I go in here, yep. So there's another kind of drawing of it. If I want to do, let's do another elevation of it. So you can see here I have a Revit elevation of it. You can see I have materials. I can change line weights, all those things. And this is live. So if I change the Rhino model, the Grasshopper definition is still running, and it would update these drawings actually in Revit. So that was generally the first thing that we tried to do, which was so many people were talking about, I like using Rhino early in the process. How do I get a decent Revit model that my BIM manager is not going to kill me about, right? So how do I get a well-organized Revit model? And so that's kind of where we started. Any questions about that?
I was wondering if when somebody starts to interact with those Revit elements and what the relationship then is to the Rhino model.
So it's important to understand that Rhino and Grasshopper can push into Revit, and Rhino and Grasshopper can pull objects out from Revit, grab their geometry and do stuff to them and things like that. But what you can't do is go at the same time, go in both directions. And so, for instance, one of the things I can do, this is just a family, right? So let me pick the footing here, and then I'm going to just say edit family, which, I'm allowed to do. Okay. And I can come in here and I can stretch this with Revit, right? That was just a Revit edit here. Now, here's the issue here. If I was to load this back into the project, Grasshopper's still in control. So Grasshopper would just change it back to the original, what it had originally. But if I had disconnected Rhino and Grasshopper here, then that edit would stay. I could change that there. And so they are real Revit objects. And depending on how you make them, you can edit them. You can always edit them in Revit. Just sometimes you can edit them in a complex way, and sometimes you edit them in a very simple way. And so, but they are in Revit once they're here.
It does to me. Yeah. That was actually you just elongating that footing kind of demonstrated a very special, I guess, connection to the Revit family and how it was actually created. Previously with something like a direct shape, it's just the shape. There's not a
Right.
whole lot you can do except re-import it and just replace it and replace it.
Right. And that's what I mean. So direct shapes work really well for temporary, for temporary objects. BIM managers wouldn't mind that if it was just for, a submittal or competition early in the process and you haven't really got far enough into production yet. And that would work great. But yeah, you're right. Then the next thing is you want to go with families and start putting them in families. And if they're in families, they're NURBs. And if they're NURBs, there is a bit more you can do with them. You can section them, you can measure them, you can things like that. And so getting them organizing them within families and inserting them is quite an advantage. You can also, for instance, you can actually use Grasshopper to drive existing families. So it could insert an existing family, for instance, and change the parameters of them. You get a little bit into the type problem, and so what is a type and when are you changing it on the instance versus the type and things like that. But that's standard, Revit sophistication that you have to understand. But yeah, so that there's a lot to do if you are willing to go to the point of doing families. So I'm also, yep, go ahead.
Sorry, I was just going to say there's also this sort of like the understanding that kind of needs to happen when you start working with Revit is that Revit is heavily parametric. So when you define, when you want to create a wall, you basically define the parameters of that wall, and then Revit will generate the geometry for you. So as Scott mentioned, you could bring the geometry from Rhino of the wall as a direct shape and call it a wall and be good. But if you have a geometry of a wall in Rhino and you want to bring it as a proper wall, as a native wall in Revit, then you might have to extract series of properties like the base curve, height, that kind of stuff, and pass it on to a Grasshopper component that is Revit aware. There's these new components that we have created for Grasshopper that kind of sort of like wrap the APIs of Revit. So there's one that says add wall, and it takes a base curve and that kind of stuff, the properties of the wall, the type of the wall, that kind of stuff, and then it would generate that wall in Revit model natively. So anything that you get out of these components, there's no difference between them if you draw it yourself or have Grasshopper created. They're, for all intents and purposes, they're native Revit elements.
Yeah, if I go into the graphic overrides here, you can see I can scroll down here. I happen to put them under site because site is a flexible, category. Not all categories can take subcategories, but in this case, you can see here's canopy, columns, panel frames, canopy panels, all those things. I can now control those through Revit and control how those objects section, how they draw, how they change curves, all those things. I can also do, I think they're called view rule overrides. So if you want to use that trick too, you can have Grasshopper set that up for you so that you can control the objects within through rules, through view rules in Revit. So all those tricks that you use in Revit to control things graphically are available for Grasshopper to control. So are there any other questions about this?
I was wondering if there's any what one of the bigger hurdles to making this work were for you, or if there's any type of geometry or kind of what the biggest sticking point from getting to this functioning from when you first started, or if there's any story there.
There's lots of stories.
Yeah.
I mean, how much time do we have? But one thing, it's funny. I'm a Rhino Grasshopper person. I had no idea what Revit was, other than I, kind of knew what it did. And before Ehsan worked for us, we got this thing working a little bit. And I remember we went into a firm and we're showing it off, and somebody said, "Do you have levels?" And we looked at him and literally we said, "Levels? Are levels important?" Not even knowing what a level was, and that, of course, they're fundamental to Revit. And so so yeah, we kind of stumbled into this, just kind of technically understanding what was happening, but not necessarily understanding Revit at all. And that's when we were able to hire Ehsan, thankfully, and with all his Revit knowledge, and that really completely changed the direction we were going, and really has allowed us to understand much better about what's important to Revit and how it's important to use. And so that's something that was a big change for us. But what we're doing now, what we're finding is we're having lots of meetings with customers, because we've solved a whole bunch of workflow problems, but I would say that we've caused more questions about workflow at the same time. For instance, you have a bunch of Revit standards. What do Rhino.Inside.Revit standards look like? Like, if you model a certain way in Rhino now, it could mean something to Revit. And so you have to have those discussions now about, do we use layers that are like categories? If how do you do this? How do you do this organization without kind of hamstringing the designers too much early in the process, not front loading your designers so much with organization that you might use later in the process. And so this, one of the sticky points that are still being worked out is how does this really work into this kind of more efficient workflow? It is more efficient. It just, people sometimes need to work a little differently to kind of, it matters now, it matters how you model in Rhino. For instance, you got to model accurately, because that model may actually, pieces of that model might actually end up at the end of production being what you produce out of, for instance.
That's actually kind of a bigger problem for people that are used to Revit and Dynamo and not have a lot of experience with Grasshopper and Rhino. So there's quite a bit, a big learning curve for them to kind of figure out the challenges of getting the right geometry into Revit and stuff. And there's, as Scott mentioned, there's been a huge amount of work being done, especially like, by Kike and everybody else on this team, to sort of like figure out how to actually bring a super accurate Rhino geometry into Revit's geometry engine, which are completely different. There's still cases that every once in a while you see, like there's an old chair family or something like that, or a model that you're trying to move between these two, and some pieces of it doesn't come in and whatnot. So all of this has been a challenge. Tolerances in Revit is quite a big challenge, and one of the most important ones is the size of Revit's API. Revit API is huge because it covers so many different categories and so many different types and whatnot. And we have wrapped as much of it as we can, but we generally prioritize based on who is asking for what they need. So that I'll in the next part of this, I'll show you how you can actually use the scripting components to kind of complement what Grasshopper does to access more of a Revit functionality there.
That actually brings up another question I had, which is just coming up with the sort of challenges that you need to solve the problems, which kind of gets back to what you were saying originally. Like you need rules, you need to push up against something so you have an objective. Are you working on real projects that are going to be built to kind of get the real world challenges you need to develop this?
Oh yeah, oh absolutely. Yeah. Scott has a much better list of all these active projects that are actually using Rhino.Inside.Revit, but there's a lot of companies out there right now, different architects and structural engineers, like all sorts of different disciplines that have started using Rhino.Inside.Revit in their actual production workflows.
And we make sure that we work really hard to try to make sure we're in touch with everybody that has an issue or has a sticky point, and we're available. And while we'll work on the project in that we'll solve whatever problem they're trying to have. They're going to do the work. But one of the really key parts about the way we develop fundamentally, it's the way we fundamentally develop Grasshopper, Rhino, everything else, is that we don't have necessarily a big plan of years of this is what we're going to add, and then you just request. We're very much driven by kind of the problems that you have right now. And so one of the things I can't emphasize enough is if you're using this, if you're trying this and you're having trouble with things, make sure to get a hold of us, because it is what drives us. You know, it is the thing that drives the product and makes it move forward. And so, you know, in that way, we do stay really close to the projects, because we're working with people that are currently in the throes of some part of the project, whatever it might be. And, you know, as time goes on, of course, the product gets better and better, and people can run for longer time without having to worry about getting us talking to us. But I highly recommend, if you're trying it out and you're having issues with something, you're trying to figure something out, make sure to get a hold of us. It's very, very important to the way we work. So, because like I said, we just learned that levels are important, you know.
And there's Bob also messaged on the chat here that just everybody knows that Rhino Inside is not only Rhino Inside Revit. As Scott mentioned, like, this was a major project in Rhino 7, reworking all the internals, all that kind of stuff, so it can actually run as a headless application or inside other applications. So there are other technologies, other products kind of like that use this technology, like Rhino Inside Revit, Rhino Inside Blender, I think is one of them that are actually being used. Rhino Inside Tekla, Rhino Inside what's ArchiCAD.
And ArchiCAD, and then Rhino Inside BricsCAD. So yep. So yeah, the Rhino Inside Tekla is actually a really new one. They have a live link, but they just did a inside application too. And it's implemented quite a bit different than this is, but for those of you that use Tekla, or for instance, you want to grab information out of Revit using Rhino Inside Revit and push it over there using Rhino Inside Tekla, you can do that. You can start connecting things up through Grasshopper, which is kind of a wild idea.
Yeah. And then the headless version of Rhino Inside, which is called Rhino Compute, is one that basically runs without a UI as a server, and you can make requests to it and solve Grasshopper definitions and all that kind of stuff. So you can actually put Grasshopper features on your web application or something like that actually uses Rhino Compute and another sort of like technology around this called Hops. That uses Rhino Compute to solve. Right, Hops is sort of like a component inside Grasshopper that reaches out to that Rhino Compute server.
Yeah. So I just want, go ahead.
I've been wanting to look into Rhino Compute a little bit more. Is Andy Payne a person that we could invite to something like this?
Absolutely. You can. Yeah, I'm volunteering Andy right now.
All right.
So,
all right.
It's right. Just you get a hold of us, we'll figure it out what day.
Okay. We'll do.
Yeah. So he's been doing more and more of that work.
Yeah. I was really excited by the idea of Rhino Inside Illustrator, which I've seen that on GitHub. But I haven't jumped into it myself yet.
Yeah, that one's difficult, and because the Illustrator API is kind of old, but there are some people trying to do that, so that is an interesting one that we're trying to see. It's really interesting. I mean, a lot of people talk about file formats and trying to be in or read and write file formats, but file formats are very, very limiting in a lot of ways. And we still do file formats and things like that, but this kind of burying, loading one application inside the memory space of another one is real integration. And so it opens up some very interesting ideas. And so we're just scratching the surface here. I want to spend like just 5 minutes just showing you this next sample, because it's kind of a different level. And then we'll have Ehsan. He can show his stuff for the last few minutes here. But what I want to show here is the idea of using Grasshopper to make smart decisions about a model. And so, and in this case, it's hangers on a ceiling, and I have a schedule here. So I'm going to jump in here, and I'll open up Grasshopper in this case. And we will, let me see if I can find the right hanger example. There we go. All right. So you can see here what's happening is that we have a few floor slabs that actually come from Revit. And then we are creating these unistruts here and placing them up against all the, based on the hangers here are created by Grasshopper. And then if I compute that, then what'll happen is that Grasshopper actually is looking for all these intersections and deciding what material that the struts are actually up against and placing the correct fitting at the top of each one of these, the correct family and you create an assembly. So these are assemblies of objects, right? So we have assemblies now we can deal with. And then as I, for instance, change the distance between these, the fittings here, and then I can recompute. You can see that it changes again. It just changes based on what these are. And I can come in here and do this and recompute. And now you can see that it continues to quote, correct the model based on this information. And I'm changing all those things. And at the same time, it's changing this hanger schedule here. And it's Grasshopper that's actually filling in what the name of the attachment is. You can grab it off the family if you want, but in this case, and it can change the height and any other parameter that Rhino knows about this information, it can actually place on the family too. For instance, indexing of these objects and things like that. But this is just a quick example of using Rhino.Inside.Revit to automate kind of a, one level up from just the simple family idea. It's actually organizing the model with a little bit more intelligence, and that makes some of these things really easy. You can imagine making scripts to do this, so that you can model things a little quicker and a little more consistency.
Would you be able to, thinking of tags and placing them, and schedules are a bummer, and this looks like it would be so incredibly useful to have to quickly have an accurate schedule pushed out.
I'll show an example of tags.
Okay, I'll wait.
Yeah, the schedules are sort of like they're kind of the easy part, because Revit actually collects the data from your model. So as long as you have the right number of instances of family that you want and the right property set on them and all that kind of stuff, your schedule should look the right way. Sometimes there's a question of like, hey, can I set up schedules and stuff like that in Grasshopper using that? We have started creating components to create views, but generally the pattern that we were going with is that because these view configurations have a lot of options, and we know that most of the people in the industry have templates for different views, we're going into the direction of letting sort of like you copy and duplicate views. So if you have like one template view for, I don't know, room schedule, something like that, and you want to create 10 of these, you can say, hey, I want to copy this and 10 times, and these are the properties that need to be set, that kind of stuff. So that's one of the approaches that we're coming up with. But there's, anything that kind of Revit API allows will able to actually do while you're inside Grasshopper.
Setting up views and setting up sheets. That was I haven't been, I got to admit, been inside of Revit, so haven't had the chance to play with the Rhino.Inside.Revit. But I did when it was still a work in progress, and the sheets and views, that was something new, and I was happy to see that, and also its ability to change schedules. Before, I forget what it was that was the hang up, something in that shared parameters are the only ones that appear in schedules, and somehow Grasshopper couldn't change them, or there was a hang up that I came across then.
Yeah, we have solved most of those problems. So try it out and see if you still see issues and stuff like that, let us know. The forum is pretty active for Rhino.Inside.Revit on the MacLean forums. And like, pretty much all the team are always there supporting, and all the other user base for Rhino.Inside.Revit. Sort of like the second part of this presentation, I kind of wanted to show you the scripting capabilities of Rhino.Inside.Revit, right? So you have a lot of experience with Grasshopper, I'm assuming. You know about the Grasshopper scripted components. So C# component and GH Python component, which is by far my favorite one. But what sort of like Grasshopper inside Revit will let you do is that previously you could access Rhino comment, and Grasshopper APIs in those scripts. Now I'm creating a GH Python script that I've set up as a sort of like a template as a user object for myself here. So I have a standard sort of like template script inside it. I kind of want to show you what you can actually do once you are using the scripted components. Notice that I'm referencing Rhino.Inside.Revit, which is the Rhino.Inside API itself, and a Revit API and Revit API UI. So that's the database aspects of the Revit API and the UI aspect of the Revit API. I can import those. I can import the original like well-known Rhino script syntax. I can import Rhino comment. I can import Rhino.Inside.Revit API or Rhino.Inside API. I can import Grasshopper API, and I can import Revit API in the same script. Because these applications are basically in the same memory space, you have full access to Revit API there. I've created a series of sort of like utility methods in here, so you don't have to worry about those much. You'll see these in the documentation that we have online. There's a really good documentation for both doing Python scripted components and C# scripted components in Rhino.Inside.Revit. The critical thing in Revit is that every time you want to make a change to the Revit model, you have to do that through something that's called a transaction. So that db.transaction is part of Revit API. You'll create a transaction and give it a name and start a transaction, make the changes in your Revit model and commit them if the changes were successful, or roll back the transaction if they weren't successful. This is Revit's way of ensuring that only one application or one add-on or one command can actually make changes to the Revit model, because it's kind of a database in that way. So that's the only sort of like tricky thing that you need to know about Revit API. I'm going to show you a couple of very simple examples here. In the first one, let's open this Revit model that I have created. This Revit model has a couple of empty elevation tags. So that's one of the biggest problems that we have in Revit every once in a while. As you create elevations around the model and you make changes to them, you delete some of them, all that kind of stuff, there's always empty elevation tags left over on different views. So let's say I want to, I'm going to move this out of my window. Let's say I want to use Rhino inside to find those elevation tags. I'm going to close this file and open the other one. So find empty elevation tags. You notice that there's you notice a lot of these sort of like specialized components now in Rhino.Inside.Revit. Like this one is an element class selector. So if I go into Revit and input, I have this one says element classes, and these are the sort of like selector components that you could go through a very big list of stuff. If you go through the help, it'll tell you how you can actually use it'll tell you actually how you can sort of like filter for other stuff. So in this case, I have filtered down my list to elevation markers. I'm looking for Autodesk.Revit.db elevation marker, which is the type that represents elevation markers in Revit. And I'm using a filter, class filter that you can find from here, a class filter, standard part of Revit API. And I'm passing that filter to query elements, which you can find here. So I'm creating a filter for that specific class and querying my Revit model for all the instances of those elements. So it'll give me all these 5 elevation tags that I have. Then in my Python scripted component here, I've created an input for elevation tag and an output that's a Boolean that says whether it's empty or not. So in that script, I can quickly check, and all of this is sort of like the boilerplate text that I generally put in my scripts. What I'm actually doing is these 4 lines. I'm checking whether the input is of DB elevation marker, just make sure that's an elevation that's been passed to it. And if it is, I'll read the property, the current view count off of it and just check if it's 0 or not. That's part of the Revit API. It's very well documented in the documentation, and I set that as output. So basically what this component is very easily doing is checking whether those elevation tags are empty or not. And then I can pass them to the list and filter down my my original list for the ones that are empty using a call pattern very easily. So that's sort of like what you're used to in Grasshopper, except that you can see that this Python is actually Python component is actually using Revit's API to sort of like interact with these elements. Another example would be this other one. Let's go through set element overrides. So I have a series of walls in this example, in this Revit model, just a couple of walls drawn here. I'm going to go to Rhino inside, open the other script. Again, I have another selector, but this time it's a category selector, so built-in categories. I'm selecting the category wall, creating a category filter this time. And you notice sometimes it's classes, sometimes it's categories. Revit API has a lot of idiosyncrasies. So you kind of have to get used to sort of like trying at different things to find the answer that you want. Not everything is super straightforward. But we have created a tool to sort of like wrap this as best as we can. Category filters, pass to query elements. This will give me all the walls that are in my model. So if I throw a panel in here, oh, not an architecture panel, this panel, I can see all the instances of these walls, these 4 walls in here. And then I'm going to use the component that gives me the active view. So this gives me the active view that is open in Revit, and pass it to my scripted component. Takes 3 inputs, the element, which would be a wall, the active view, and whether I want to mark that as half tone or not. So I'm passing a Boolean value variable in here. And in my script, I am saying, hey, check the inputs and all that kind of stuff, but basically create a new instance of override graphic settings, set the halftone, run a transaction, because now I'm changing a model. I'm not querying stuff only from it. I'm not just reading, I'm making changes. And I can say, ask the view to set a new element override for the element that's passed to it. So what that means is that all these walls are set halftone now. But because it's Revit API, all these actions are being done natively. So if somebody else on the other side of the team, and this model could be on BIM 360 or anything like that, they can go in the visibility graphics by element and see that halftone is checked. So all of this is basically just using Stratum Revit API. Another example, which is sort of like a slightly more complex example, and that would be a way to, let's say, create tags and elevation tags and stuff like that in a Revit model. So I have this topography model that sort of like has this like shape in it. I can actually delete this one because I don't need it. I'm going to Rhino inside and open Rhino. So one thing that you sort of like want to get used to is that Rhino is always running in the background, whether you are seeing the window or not, right? It's just inside the memory space of Revit. So these are not 2 different applications, just 2 different windows to the same application. So I'm going to open a top elevation, spot elevation model in here, which has that basically that that's sort of like topography that I created. And I created something simple, it's grid-like and whatnot, so we can sort of like show how these elevation tags could be placed. But I'm basically loading that, and I'm closing the Rhino window. Rhino is still open in the background, still has that active document, it just doesn't have a UI. And I'm going to go to my Grasshopper and load the Grasshopper definition for this one now. Okay, so see, I brought this as a topography, that geometry, into my Revit model. So I grabbed a mesh from Revit, from Rhino, I'm sorry, and I passed it to the topography component that creates a topography in Revit. That's a native Revit topography from a mesh in Rhino, right? So I got that one. I wrote a Python script that can grab all the points of that topography for me. And that's very simple. Topo, or it's sort of like a DB architecture topography surface in Revit, has a property that's has a method that can give you all the points on that topography. And I sort of like, in this case, all the points that I'm getting, so this PT is a point that comes from Revit API. So we call it a Revit point. right? I need to convert that into a Rhino point. That's when where the Rhino.Inside.Revit API comes into play. So I've added this import extensions from convert.geometry, which is the part of the Rhino.Inside.Revit API. And what it does is that it basically gives me this method that I can just very easily call on a Revit point and convert it into a Rhino point, right? So I'm creating a list and passing that list to the output. So the list that comes out of this, they're all standard Rhino points, and they visualize correctly in Grasshopper, and you can use it with anything else that in any other component in Grasshopper that can take points. So I'm passing that in, and I'm going to go into the sort of like level here, and I do have, let's drop a elevation tag in here. So this is another part of the sort of like challenges of working with Revit API. Not everything is very straightforward. So for specifically spot elevations, Revit API doesn't actually let me to create one. So I have to have one created, and then I can copy it and set its new coordinates. I'm going to close that window, go to Rhino Inside, open my Grasshopper window. I'll put it on the side here. And then this component here, graphical element, is supposed to reference that instance of the elevation tag that I have here. And as soon as I do it, you can see that it will automatically generate a copy of that elevation tag for the sort of like the different points that I have. So I can see these are all 0. And then as I go up, the elevation on these elevation tags changes. And this is a standard Revit elevation tag. All I did here in my scripted component here was that, again, check the input, started a transaction. So that's the standard transaction block that we talked about. What I'm actually doing is I'm using an element transform utils, which is part of Revit API, to copy that original instant, the elevation tag, spot elevation tag, to a new location. And I'll let Revit handle the rest of the stuff. So I'm just using the API to make a copy of that. And because of whatever that the elevation tag is sitting in relation to the topography, it will sort of like read the correct elevation on the tag. And then you can do it in your script too, but basically you can get rid of the extra ones that you have. So these are a couple of sort of like different examples to kind of show you the power of all these scripted components inside Rhino, inside Revit, and whether you can almost do anything you want to do, as long as basically Revit API supports it. The last thing that I wanted to show you is that in Rhino inside Revit, as you might have noticed, comparing mine to Scott's, I have an extra panel in here that says my Rhino inside Revit tools. This panel is generated from a series of Grasshopper definitions that I've placed in my download directory, Rhino inside Revit tools. There's an example directory with a couple of tools in here, and that example directory has another tool here. So you can see this structure of these files are actually represented just like that over here. There's a examples dropdown, create a sphere, and a couple of different Grasshopper definitions. Now, the icons are actually stored in Grasshopper definitions. Grasshopper definition can have Grasshopper definition properties, information, description, title, that kind of stuff. So Rhino inside Revit will read those and will create Revit UIs for them. The way to do it is to basically just go through Rhino inside Revit settings, scripts, and add the path of this collection of Rhino inside Revit scripts that you have to this settings. And then next time you load your Rhino inside Revit, it will load all those stuff in your toolbar. And assuming that you kind of want to deploy this for all your other users and other coworkers at the office, you can actually say, hey, in the options to maybe compact ribbon, maybe that one. So it would always keep these two closed, so you can focus mostly on the tools that you have created. So in this example, if I open the 3D modeling here, and I'm going to turn off the Grasshopper preview, and you notice that we have an independent preview for the Grasshopper geometry inside Revit. That doesn't turn off the one that's in Rhino, it turns off the one that's in Revit. And I can go say, build a sphere. Notice I don't need to open the Grasshopper definition, anything like that. So you can almost make these Grasshopper definitions just like tools that do things in your model, and I can very easily run them right from here.
I love the idea of not having a coworker go inside of Grasshopper. They get so intimidated so quickly, but giving them a button to push and even being able to quickly throw an icon on it is really useful, really powerful to disseminate the tools that a person might make.
Yeah, you can place all these like Grasshopper definitions somewhere on your network, or I don't know, they could be stored as GHX text files, so you could even put them in a GitHub repository and sort of like share it within everybody, that kind of stuff, and have Rhino inside Revit load those tools in Revit UI very easily. The other thing that you also have this Grasshopper player button in here that you can actually, it works kind of like Dynamo Player if you have used that one, but you get to pick whatever Grasshopper definition that you want and would run it that way. So that's sort of like the underlying feature that the UI buttons actually use.
Would all of the components used in these definitions need to be native, which is just not reliant on an extension that isn't installed on somebody's computer?
No, so Rhino 7 comes with a package manager that's called Yak. So
Okay.
from now on, every time you have a Grasshopper and open a Grasshopper definition that has components that belong to a different plugin, different Grasshopper add-on, a lot of those plugins can be actually automatically installed with Yak. So we'll show you a prompt and says, hey, like, you know, human UI, those kind of add-ons and whatnot. And when you say install, you install those and it would load your Grasshopper definition correctly. So a lot of this stuff is actually a lot simpler now.
You do have to make sure that, Yak will alert you, but if you're trying to run it in Player, it won't automatically install it. So you have to, you do have to make sure you have the plugins. But if it's in, so Yak though can automatically, or can alert people when they don't have all the right, even down to the version of different plugins.
Yeah, but it does, the Grasshopper that's inside Rhino.Inside Revit, it does have all the native Revit components that we have created. So you don't have to worry about those. It's basically just setting up, if you're deploying Rhino to your users, it's basically just setting up whatever add-ons, Grasshopper add-ons, Rhino add-ons that you want them to have. And that works with your definitions and stuff like that. And they're good to go. But the same version of Rhino, it's sort of like the same Rhino 7 installation on your machine with all its add-ons and Grasshopper add-ons and whatnot that gets loaded inside Revit.
This has been absolutely fantastic. And if we could get the recording when that's available, I have several people on my team to pass this along. They were regrettably unable to make it tonight and very excited as well. And this has been just way more wholesome goodness than I was prepared for.
And make sure too that we have a forum. Our forum and our website has lots of documentation and lots of videos and samples. And make sure to get on the forum and ask, because Ehsan's up there and Jaffe's up there and Kike, who does a lot of the heavy duty programming, is on there too. And so make sure to get in contact with us as you're working through this. So
yeah, so that's the sort of like, if you would search for rhino3d.com inside Revit, it'll take you to the latest version, the current version, which is 1. That's the documentation for that. You can download it from here, download Rhino 7 from here. The getting started guide is sort of like a basic 5-minute thing that gets you started with all the stuff that we talked today basically about. Just one article that goes through these different sections. But the guides is the one that you kind of want to sort of like every once in a while check to know more about different Revit families and how to work with them. Like, for example, curtain walls and systems, all of those are kind of described in here, and you can sort of like see how you can query them, analyze them, create them, that kind of stuff, whether it's like, curtain walls, curtain systems, basic and stacked walls, that kind of stuff. So there's a lot of material in here. At the bottom of this, you have the Python component in Revit that takes you through how to set up your Python component with the templates and all of this boilerplate code, all that kind of stuff. And same thing for C# at the end of that list. You also have that one if you want to use C#. And then we have forums that will take you to Rhino Inside Revit forums. that we talked about that Scott mentioned. And there's also some reference documents and stuff like that in here, like the release notes. So if you want to stay on top of the recent changes and whatnot, you can actually take a look at these and see what does change between different versions. Oh, and we have, I forgot to mention this, we have a lot of different materials under Discover. So if you want to go through this, I'm going to mark all of these as red on my machine. And they're kind of organized based on courses, tutorials, examples, podcasts. A lot of this is also from like other presentations like this, that kind of stuff.
This is awesome. Thank you. I'm personally like just as excited as this is a paradigm for working in other software as well. I want to explore Blender and Illustrator. I think before, as we wrap up, I'm going to hand it to Jacob and we'll just talk about some group stuff. Anyone has any recommendations of things they'd like to see in the future, be that Revit Inside Rhino related or general Grasshopper things? We're very interested in being not just an architecture group, but multidisciplinary. So we're interested in hearing any feedback from people, but I'm going to hand it over to Jacob now.
Yeah, if a lot of new faces, a lot of new attendees at this event, I was really excited by this, and no doubt because of the material and because of Ehsan, that it generated a lot of excitement. And what's something else that would be similarly desirable to learn more about, and who might we get in touch with? This group started quarantine, wanting to connect with people, and who better than the rare breed of Grasshopper users? There's always just maybe one or two in an office, and to be able to pull everybody together and share thoughts and approaches seemed like a very, I don't know, it's turned out to be quite inspiring. I guess I always come away super excited about the technology and what continues to become available. Been possible, and I guess I just wonder if there's anything about any new developments that you'd like to know more about, or do know a lot about, and would be willing to share your expertise. We certainly are open to it. Our events have typically been either a person will present projects in which they've used parametrics in the process and production, or it's some tool that is helpful to similar ends. And right now I'm kind of into Shape Diver. It's a product, but what I love about it is democratizing design and what parametrics can do toward that end too. The designer makes a system for other people to fill in with their needs and desires. So Shape Diver and the way that it can be used and disseminate the power of Rhino and Grasshopper and Rhino.Inside.Revit is really attractive right now. So that also comes into the Rhino compute being of interest. But if there are any other extensions that would make you come back, and visit again, that you'd like to learn more about, I would certainly love to hear about it, and I'd do my best to find somebody who could get us smarter about it.
I'd say definitely reach out to Andrew Payne.
Yeah.
Because that's like for all the Power Grasshopper users, that's going to be very exciting.
Yeah, he's like a hero. Firefly, him and Jason Kelly Johnson. Like, I don't know. That'd be very exciting. So that hopefully is going to be on the horizon. But the most immediately, think we'd like to do some Shape Diver stuff, and we recently were introduced to a 3D clay potter, a CNC clay 3D printer, and hoping to come up with some projects for the group to put that thing to use. So yeah, Dandro. So please come back. Lots of things in 2022 that we got.
Yeah, I just want to say thank you, Ehsan and Scott. Thanks for spending the time to present to us. Really excited, and I think a lot of people are, ostensibly the internet as well, because we've had a 5-fold membership. So thanks a lot.
We got the Ehsan bump.
That's right. That's right.
there's
All-star that he is.
Hey, this is Meron. I had something quick. I'm new to this group, just moved to Portland. Great. Thank you all for organizing this. Just wanted to thank everyone. I think Rhino.Inside is a great tool, and future sessions on it wouldn't hurt for sure. If we do more about it, I'd love to see if there's any automations that could be set up so more people could use it. Dive a little bit deeper into it. How we can automate that connection between Rhino and Revit, so you don't have to necessarily go through all the setup. Maybe someone can set it up and it automatically does the back and forth for the team. That's where I see maybe it could be a next step. Revit right now has a lot of plugins for automations, and if Rhino.Inside could somehow take advantage of those, that would be amazing.
That's an interesting to access other add-ons inside of Revit. Does Rhino inside of Revit and Grasshopper?
As long as as long as the plugins have SDK API access themselves in Revit. So can you access them with Python? Can you access them with C#? If so, yeah, we can do it.
Awesome.
And as far as Rhino cares, Grasshopper plugins is only one type of Rhino plugins that you can create. So you can create Rhino commands that run in Rhino inside Revit. They can access Revit API as well.
It's true.
So that's like anything that's inside this same memory space, they can access all the available APIs.
Yeah.
I like the idea of digging into this. This is really, a game changer. So digging into Rhino or Rhino inside of Revit more and looking more specifically at the process. It is different, and the way that the components are set up, or the way that the workflow is, it really is catering to Revit, and it's like weird structure, but and it can be a little tricky to get started. And maybe sometime soon we should hold how to make walls and apply new different assemblies.
Yeah,
that'd be cool.
Yeah, it is interesting in that it takes the talent you have with Grasshopper, and then now you don't only have to just impact Rhino, you can impact your Revit desks too. And so, it really expands, or, if you have Tekla or other things too, but the ability to, your understanding and knowledge of Grasshopper now becomes that much more valuable. So.
You all have raised my stock for me, so thank you.
There you go.
Yeah, I didn't even have to do any work.
Well, we appreciate everybody using Grasshopper and Rhino, and that's something. I mean, it's what drives us forward. So keep it up and keep yelling at us and complaining about it, and asking us questions about where it's not working very well, and we'll continue to try to make it better.
I certainly appreciate that. Excellent. Thank you so much.
All right.
Again.
Thank you.
Yeah. All right. Yeah.
Thank you, everyone.